Today, I'm going to talk about the big reason why your arteries are calcifying and potentially turning into bone. Now, since heart disease is the #1 killer worldwide, I think it's important to discuss a nutritional aspect of this problem that gives you something you can do about it. And this video is primarily going to talk about the calcium part of this problem more than cholesterol or other problems with the heart. What are the top warning signs that someone can get with a heart attack? Well, #1, you'd have chest pain, especially if you're exercising or exerting yourself or going through emotional stress. And the chest pain is relieved when you rest. That is a really good indicator that there could be a heart problem. And then we have referred pain to your left shoulder or arm, okay, or even your back or the jaw or this side of your head. Since the heart is slightly on the left side, it can refer to that area right here. All right, #3, heartburn without really having heartburn, okay? So you could have just a burning feeling in your chest that has nothing to do with acid. #4, shortness of breath, especially exercise or climbing stairs. And #5, there is no symptoms. You just drop dead of a heart attack. Now, the big problem with calcium is the hardening of the arteries. And now we lose the elasticity. We don't have the ability to adapt to stress, blood pressure, etc. It just becomes hardened, and that puts a huge stress on the entire body. Now, what's interesting about calcium in the arteries is it's not passive. You just don't end up with calcium in the arteries for no reason. It's an active thing that occurs in certain conditions. Now, as far as the type of calcium in the arteries, they are finding that it's the same type of calcium that is in your bone, hydroxyapatite. In fact, this type of calcium makes up 70% of the calcium in your bone. And the vascular system is the second most calcified tissue in the body, excluding your bones, okay? Now, we do know as people age, their body starts to calcify, okay? So they start having calcium deposits in their joints, of course, in the arteries, in their eyes, in their tissues, all over. And so this video that you're watching is a very important video to understand the mechanism and what you can do about it. But we do want to keep the bones calcified, and we want to keep the other tissues not calcified. Now, like I've already mentioned, we don't want our arteries becoming bone. And a really good test to do to determine if you have calcium in your arteries is a CAC score. It stands for coronary artery calcification score, okay? I had it done. You want the results to be 0, no calcium in the arteries. That puts you at a very, very low risk of heart attacks and mortality. So the CAC test is not only one of the best predictors of whether or not you're going to have a heart attack, it's also a really good predictor for mortality in general, because calcification in your tissues is a pathological sign that there's something seriously wrong with your health. Now, the other point I want to bring up is the majority of people over 6 years old have some type of calcium building up in the arteries, which again, like I said, it should not be there. Now, I want to cover something about bone tissue. In your bones, you have 2 types of cells. You have the osteoblast, and then you have the osteoclast. And the osteoblast are the bone cells that are building bone, okay? They're building bone up, and they're creating bone. And then we have the osteoclast, which actually degrades or breaks down bone. So we have these 2 things happening in the bone at all times, right? So if you have too much of this, you get osteoporosis. And then if you have too much of this in your arteries, especially, you start getting calcification in your bones. Your arteries actually are turning into bone, which is it's just bizarre. And if we're talking about inside your arteries, we're talking about the endothelium, which is the inner tissue of your arteries. There's actually stem cells, okay, in this layer of your artery that are osteogenic. What does that mean, osteogenic? It means that they're capable of producing bone. And so a stem cell is an undifferentiated cell. It's kind of like a blank slate that has the potential to turn into a certain cell, depending on what the body needs. So when someone starts developing bone tissue in their arteries, that is a big problem in the differentiation of what the stem cell should turn into. Now, if we take a look at autoimmune diseases, we have the same problem. We have a differentiation problem. Your immune system is unable to differentiate between a normal cell and a pathogen. It ends up attacking your own cells. And so with this problem, it's very similar. It's a differentiation problem. Well, guess what? Vitamin K2 is a vitamin that was recently discovered. Now, when I say discovered, I mean that it's been there all this time. We just did not recognize it. And vitamin K2 is involved in this differentiation problem. If you have sufficient vitamin K2 in your body, you're going to inhibit this calcification problem. You're going to inhibit the osteoblast, the cell that forms bone in the wrong place. So vitamin K2 is a potent stimulator of a certain protein called matrix GLA protein. And this protein inhibits vascular mineralization and is dependent on K2. So if you don't have K2, this protein is not going to inhibit vascular mineralization or calcification. Vitamin K2 is becoming more and more popular. There's over 3,500 research papers on vitamin K2 that you can look up. And so vitamin K2 is all about keeping calcium out of the arteries and keeping calcium in the bone and making your bones very, very strong. Now, I believe that the majority of the population is deficient in vitamin K2, at least subclinically, okay? And I'm going to tell you why in the next section. All right, why are we deficient in vitamin K2? Well, what's interesting about K2, it's made by bacteria, okay? It's different than vitamin K1, which actually comes from leafy greens. And so vitamin K2 is made by bacteria. In fact, even in your gut, you can convert vitamin K1 to K2, okay, if you have the right microbes. So if you have gut problems, okay, and you don't have the right microbes, you can't make this conversion. That's number one. Also, as far as an absorption problem, vitamin K2 is a fat-soluble vitamin, which means it's dependent on bile, okay, which is produced by the liver. And if your liver is fatty, which you can pretty much tell if you have a fatty liver if you have a belly, okay? If you have belly fat, you have a fatty liver. The more damage to the liver, the less bile you're going to make and the less K2 you're going to absorb. If you don't have a gallbladder, if you have a congested gallbladder, if you have gallbladder problems, if you have a bile deficiency, you will also have a problem absorbing vitamin K2. If you have inflammation in your gut, if you have gastric bypass surgery or some type of problem with your gut, that can inhibit your absorption of K2. Also, if you don't have enough fermented foods, you could be deficient in K2 because certain microbes in the fermentation process can actually make vitamin K2. So let me give you some examples. We have natto, which is a fermented soybeans. I think it's very popular in the East, not in the West. Sauerkraut has K2. Okay, you know what that is. Cheese is a fermented product. Raw cheese, especially if it's hard cheeses or soft cheeses from Europe, because usually they have raw milk cheese, you're going to have a good amount of vitamin K2. If you actually can get raw butter, okay, and grass-fed butter, you have a good amount of vitamin K2. And guess what? Butter is a fermented product, okay? And then, of course, we have kefir, which is one level above yogurt. If that's made from grass-fed animals, you're going to have a good amount of K2. And of course, if you're getting conventional yogurt or conventional kefir that is pasteurized and sweetened, you're probably not going to get very much K2. Now, vitamin K2 is also in egg yolks. It's also in beef liver, especially if it's grass-fed. It's in sausage. It's basically in fatty foods. So if you're on a low-fat diet, okay, you might be omitting these right here. And what's really bizarre to me is take a wild guess what mainstream recommends for cardiovascular disease. Okay, if you guessed a low-fat diet, you are correct. What do they recommend? They recommend fruits, vegetables, grains, at least half whole grains, and half refined grains, and they even allow a good amount of added sugars to that diet. And so this is just another one of those examples of finding out what they are telling you to do or what mainstream is telling you to do and do the complete opposite. I mean, even take a look at statin drugs, right? Statin drugs inhibit vitamin K2. And I'll put a research paper down below to back that up. Now, as far as the type of vitamin K2, there's a lot of different types. One type in these foods right here is MK4. But if you get MK4 in a supplement, they make it synthetically. I recommend the natural form of vitamin K2, which is MK7. And I also recommend taking it with vitamin D, okay? Now, as far as the ratios go, if you're taking 10,000 IUs of vitamin D3, you would take 100 micrograms of vitamin K2. One last point about vitamin D that's actually quite interesting. Some people are concerned about the toxicity levels of vitamin D3, right? Well, really the only side effect from taking very large amounts of vitamin D3, I'm talking like several 100,000 IUs of vitamin D3 over a month, okay? The only major complication is hypercalcemia. That means too much calcium in the blood. Well, guess what vitamin K2 does? It helps to keep the calcium out of the arteries and in the bone. That's why I recommend taking them together. And on that note, I think you might find it interesting in this next video on vitamin D toxicity. Check it out.